If you don't master acceleration, you'll get a 0 in mechanics. Your electromagnetism score will be cut in half. As long as you're studying high school physics, acceleration is the very foundation of everything. If you don't learn it well, you'll really be letting your future self down in 2 years. Your thoughtful teacher, Xiaoshu, has already summarized it for you. In this lesson, we'll help you completely master acceleration. I'm a physics teacher who made a comeback from being a poor student, so hurry up and give me a follow. I will be the man to guide you through all of high school. I've prepared a summary of essential models for your high school physics exams. The biggest difference between middle school and high school physics is, if you want to do well in high school physics, you must master these models. First, let's look at the concept of change in velocity. So why do we need to understand the change in velocity? Because acceleration, what does that mean? Acceleration A is equal to delta V over delta T. And here, the change in velocity is this delta V. So first, let's understand the change in velocity. How do we do that? This is very easy to understand. For example, say your velocity changes from 1 meter per second and then becomes 3 meters per second. So the velocity increased, right? It accelerated. So how much did the velocity change? What is the change in velocity? It's very simple. Just take the final velocity, 3 meters per second, and subtract the initial velocity, 1 meter per second. And there you have it. The delta V here is equal to 2 meters per second. But, as we know, is velocity a vector or a scalar? It's a vector, so in most cases, we also need to discuss its direction. If it's in the positive direction, it's positive. If it's in the negative direction, it's negative. For example, you're moving to the right. Let's say right is the positive direction. The velocity to the right is 1 meter per second. Then it changes to a velocity to the left of 3 meters per second. What does that mean? It's like you turned around. After turning around, the velocity changed. So in this case, is the change in velocity still 2 meters per second? No, it's not. Why is that? Because, look, we defined the positive direction as to the right, so 1 meter per second here is no problem. But after you reverse, when you move to the left, your velocity, the magnitude of your velocity is 3 meters per second. But strictly speaking, your velocity should become negative 3 meters per second because the velocity has reversed, right? So at this point, your change in velocity should be delta V equals negative 3 meters per second minus 1 meter per second equals negative 4 meters per second. This is your change in velocity. So the change in velocity is itself a vector. It has positive and negative values. We just need to subtract the initial velocity from the final velocity to get the change in velocity. Then, based on whether it's positive or negative, we can determine its direction. So this is the expression for the change in velocity. Delta V equals V2 minus V1. 2 refers to the final velocity and V1 refers to the initial velocity. Delta V is what we call the change in velocity. Now this delta thing, we actually see it quite often, right? So when do we see delta? For example, a formula we've learned before. Q equals Cm delta T. Sound familiar? For those of you just starting high school, it should be familiar, right? What does this delta T mean? This delta T refers to the change in temperature. So delta plus a physical quantity represents the change in that physical quantity. When we were learning about temperature change, we said if it goes from 1 degree Celsius and changes to 100 degrees Celsius, then its change in temperature, delta T, is 99 degrees Celsius. So it's the same when applied to velocity, right? Delta V is the same, it also represents its change. So later on, we will see all kinds of such changes. For example, if height is h, then the change in height is delta h. For example, from a height of 1 meter, you jump straight up to a height of 9 meters. So you see, what is the change in height, delta h, here? The height changed by 8 meters. This is the change in height. That's how you understand it. Next, let's look at this problem. Let's practice together. What should the change in velocity, delta V, be here? We see a basketball in free fall from a certain height, and then its instantaneous velocity before hitting the ground is this. After colliding with the ground, its magnitude changes to this as it bounces vertically upward. Taking vertically downward as the positive direction, we must pay attention to which direction is positive, because this determines our direction and our signs. What happens at first? Initially, before hitting the ground, it's moving downward. The velocity is 8 meters per second. And then, well, it bounces back. It rebounds at a speed of 6 meters per second, and it's bouncing vertically upward. So, strictly speaking, look, its magnitude is 6 meters per second. But strictly speaking, its final velocity is negative 6 meters per second. It reversed direction, right? The velocity's direction is now opposite. Okay, so for the change in velocity here, we take the final velocity, negative 6 meters per second, and subtract the initial velocity, 8 meters per second, which gives us negative 14 meters per second. This is the actual change in velocity. If you miss the negative sign, it's wrong. Next, let's look at the second concept about acceleration. So what is acceleration? Acceleration doesn't necessarily mean speeding up. It can also mean slowing down. Acceleration refers to how fast the velocity changes. For the word acceleration, you should actually separate the words add and velocity. It should be add velocity, not acceleration. You have to be precise with the wording. It's add velocity. As for the velocity that's added, we don't know if it's positive or negative, so it can be speeding up or slowing down. So why do we use delta V over delta T for how fast the velocity changes? Let's think about it this way. We know what velocity change is. The change in velocity is delta V. Okay, so how fast does the velocity change? For example, we all go from 1 meter per second to 3 meters per second. Hey, the change in velocity is the same, it's a change of 2 meters per second, but some are fast and some are slow. Someone might complete this acceleration in just 1 second, while another takes 2 seconds, so we have to divide by time to get how fast it changes. Right? For any physical quantity where you want to study how fast it changes, you have to divide by time. Like what? For example, the displacement we just learned, right? Displacement delta x. Displacement refers to the distance it moves. It describes its state of motion. So how fast or slow is its motion? We just divide the displacement by time and we get its velocity. Another example we've already learned is what is power. Power refers to how fast work is done. So what is work? Work is W. Okay, so for the rate of work, we just divide the work by time and we get the power. It's the same principle. So if you want to study its rate, you just need to divide this quantity by time. Okay, in this case, delta V, as we just mentioned, is the change in velocity. And delta T is the time required for this change to occur. So is acceleration a scalar or a vector? Well, let's see. Acceleration equals A equals delta V over delta T. Here, delta V, as we just said, is a vector, and delta T is a scalar. So a vector divided by a scalar is still a vector. Its direction is determined by what? Well, its direction follows delta V. In its expression, only delta V is a vector. So, its direction is determined by the direction of the change in velocity. Okay, let's look at this problem. The initial velocity of the soccer ball is v1, and its direction is horizontally to the right. The collision time is 0.1 seconds. After the collision, the magnitude of the rebound velocity is v2. Actually, there's an implicit condition here. What is it? It's that the magnitude of the velocity after rebounding is 7 meters per second. It emphasizes the magnitude. Actually, there is a different direction here. Originally, you see it's to the right. Later, what happens? It rebounds. If it rebounds, it must go to the left. The positive direction is not specified here, so let's assume the positive direction is to the right. So the initial velocity is v1, 10 meters per second. Then what should v2 be? It should be negative 7 meters per second if we consider the direction. So what is the magnitude of its acceleration? The magnitude of the acceleration is equal to delta v over delta t. Here, delta v should be negative 7 meters per second minus 10 meters per second. Then divide by time. What is the time? 0.1 seconds. Okay, so that should be negative 170 meters per second. So the magnitude of acceleration, actually, what is it asking here? You need to pay attention to what it's asking. It's asking for the magnitude of the acceleration. Since it's the magnitude, we don't need to include the sign. Just write 170. Okay, here it asks for the direction. Okay, we define the positive direction as to the right, and the data we got is negative. So it must be to the left. Therefore, we fill in horizontally to the left. Done. Next, let's look at the third question, the case discussion of acceleration. Why is there this case discussion? Because as we just said, sometimes it only gives you a magnitude. Then, whether it's positive or negative, we can judge based on the actual situation, like with this soccer ball here. But sometimes there is no actual situation, it just gives you a magnitude, and you don't know which is positive and which is negative. For example, here we see a particle moving in a straight line with constant acceleration. Within 2 seconds, the magnitude of the velocity changes from 2 meters per second to 4 meters per second. So how many situations are there? The magnitude of the velocity changes from 2 to 4. So what could it be? It could be that 2 meters per second becomes 4 meters per second, or it could be that 2 meters per second becomes negative 4 meters per second. Negative 2 meters per second becomes 4 meters per second, or it could be negative 2 meters per second becomes negative 4 meters per second. There are 4 scenarios, so for these 4 scenarios, we'll discuss them separately. Okay, first, what do we need to calculate? Acceleration. Okay, for acceleration, let's first find its delta v, the change in velocity. For example, if 2 becomes 4, then the change in velocity is 2 meters per second. What if 2 becomes negative 4? Then it's negative 6 meters per second. Okay, what if negative 2 becomes 4? Then it's 6 meters per second. What if negative 2 becomes negative 4? Then it's negative 2 meters per second. Then we calculate the acceleration, delta v divided by delta t, the time is 2 seconds. Okay, so 2 meters per second divided by 2 seconds, that's 1 meter per second squared. Okay, then let's get these results one by one. This is negative 3 meters per second squared. This is 3 meters per second squared. And this is negative 1 meter per second squared. So we've also obtained these 4 results. So its acceleration could be one of 4 possibilities. So is it definitely positive 1 meter per second squared? That's definitely wrong. Okay, could it be negative 1 meter per second squared? Correct. C is also correct, and D is also correct. So this is a multiple choice question, and the answers are B, C, and D. Next, let's look at the 4th knowledge point about acceleration and deceleration. Okay, so how should we look at acceleration and deceleration? Actually, what does acceleration mean? It means the magnitude of its velocity has increased. Deceleration means the magnitude of its velocity has decreased. So what are we looking at? We're looking at the magnitude of velocity. For acceleration and deceleration, what do we never look at? We never look at direction. If you move forward and your speed increases, that's acceleration. If you move backward and your speed increases, that's also acceleration. So what do we look at? We only look at the magnitude of the velocity, only the absolute value of the velocity. We only look at this value. If it gets bigger, it's acceleration. If it gets smaller, it's deceleration. Okay, so in the case of acceleration, for example, if you're moving in the positive direction, you move in the positive direction, you go from positive 1 to positive 2. Okay, that's acceleration. What if you're going in the negative direction? You move in the negative direction, you go from negative 1 to negative 2. Although from a mathematical perspective, this number has decreased, from a physics perspective, it has indeed accelerated. Because this negative sign indicates its direction. You go from negative 1 and then it becomes more negative, becoming negative 2. You go from positive 1 and it becomes more positive, becoming positive 2. So what do we look for in acceleration? If you're moving in the positive direction, you have to become more positive. If you're moving in the negative direction, you have to become more negative. Only in this situation can you accelerate. So in the case of acceleration, if your initial velocity is greater than 0, then your change in velocity must be greater than 0, or in other words, the acceleration must be greater than 0 because their directions are the same. In this case, it's acceleration. Or if the initial velocity is less than 0, okay, then both of them are less than 0. In any case, they are consistent, are both less than 0. In that case, it must be acceleration. Then conversely, it's deceleration. So what's the rule for acceleration? Basically, the initial velocity and the change in velocity are in the same direction. Whether it's the change in velocity or the acceleration, as long as they are in the same direction, it must be acceleration. And the opposite is deceleration. V0 is greater than 0 and A is less than 0. This means the initial velocity is positive, but the acceleration is negative. So what must it be? It must be deceleration, right? Because here, the two signs are opposite. Okay, if both are less than 0, it must be acceleration. So let's summarize the rule for acceleration and deceleration. For deceleration, what must be true? If V0 is greater than 0, then A must be less than 0. If V0 is less than 0, then A must be greater than 0. Anyway, these two must be opposite. For acceleration, they just need to be the same. Greater than 0, greater than 0. Less than 0, less than 0. And you can replace A with delta V because the direction of these two is always the same. Okay, so let's look at question 5. For question 5, let's see which one is correct. First, look at option A. When the direction of acceleration is the same as the direction of velocity, if the acceleration decreases, the velocity will decrease. Actually, when we look at acceleration, regardless of whether it decreases or not, as long as the direction is the same, then the velocity must be increasing. It's accelerating, so A is wrong. For B, the magnitude of an acceleration of negative 5 meters per second squared is greater than the magnitude of negative 2 meters per second squared. No problem, because acceleration is a vector. What do we look at for vectors? For vectors, we only look at the absolute value. Now, let's look at C. When the velocity is 0, the acceleration must also be 0. Well, that's not necessarily true. Why? Because at the moment the velocity is 0, you don't actually know what the acceleration is. Why? Because velocity only represents its state at that instant. But acceleration, well, it's about how the velocity is changing, how fast it's changing. For example, if you are always at rest, the velocity is always 0. Okay, then the acceleration is 0, no problem. But what if you are in a state of change? You go from negative 1 meter per second to 0 to 1 meter per second, see? You are in a process of change, right? A process of change. So in this case, you do have acceleration. It's just that at some point in the middle, your velocity becomes 0, but the velocity is still changing. So this statement is definitely wrong. It's not that it must be 0, it could be 0. For example, let's see, well, in this process, we go from negative 1 meter per second and eventually become 1 meter per second, right? In this process, we only used 1 second, okay? So for this process, the acceleration, assuming the acceleration is constant, what can we calculate the acceleration to be? It's 2 meters per second squared. Okay, after calculating the acceleration, we see that it's not equal to 0. It's just that at a certain moment, the velocity is 0, but throughout the entire process, it has acceleration. D. An object with a very high velocity cannot have 0 acceleration. Actually, what does 0 acceleration mean? 0 acceleration means its velocity doesn't change. It means its delta v is also 0. It means its velocity doesn't change. If you maintain let me give an extreme example. You maintain a speed of 10,000 meters per second, maintaining this speed at a constant velocity in a straight line. The magnitude of your acceleration is 0. Why? Because the velocity hasn't changed. For an object with very high velocity, acceleration can also be 0. So the only correct option is B. If you understood, please like this video. I'm Xiaoshu, here to help you love physics. I used to be just a student who was bad at physics, but after I mastered the correct methods, I made a successful comeback. I know that many students, after entering high school, immediately find they can't understand physics. This isn't because you've gotten worse, it's just that the subject of physics in junior high and high school is fundamentally different. For high school physics, as long as you build the necessary models and reconstruct your knowledge system, you can get high scores. These are all students from our high school physics reconstruction camp who improved their scores and contacted me to learn about the course. That's all for today's video. If you enjoy the free content, please follow, subscribe for the next episode, and I'll keep bringing you valuable content.